Assalamualaikum. So today our group, which is group 2, we want to present about palm plantation development for our subject ECV3511, which is geometry engineering. So my group member is Muhammad Azhar Afizuddin, metric number 2000225. Myself, Sifra Tabungan Rahim, metric number 201148, and Alicia Aula with metric number 201221. So, for introduction, Indonesia, Malaysia, and Thailand are home to the largest population of oil palm, which is alias gonensis in Southeast Asia, where they are grown for their edible oil. So, oil palm are produced as a monoculture for industrial purpose, and among other oil crops such as soybean, rapeseed, and sunflower, oil palm produce the highest oil yielding capability. Okay, for choice of land, we choose area in Rumpas Tawau, Sabah in this proposal. So we have do some research. So Tawau have most of the soil is alluvium. So the best soil type for the oil palm are loamy and alluvial and having sufficient soil moisture. So our oil palm development site was evaluated using GPS, RS, and GIS technology. Okay, for methodology, this is for software methodology. So the different global positioning system we use is DGPS and handheld GPS. So we use this for ground truthing and tracking. And to define the study areas for geographical boundaries and create a digital trend models, we also use the GPS. And for Spot 5 portal, the raw image in tag image format, which is the IFF. So actually this picture is this is from Google Map. So next for how to plant the oil palm, firstly we prepare the site. So actually we need to begin by marking the boundary of plantation, which is the area that we choose. Next, we pegging the planting pattern. So the planting pattern to make the plant not separate, so it will be more nice. And next, we planting up the old palm seedling. So we dig a hole and do the palm seedling, and lastly we putting wire netting around the seedling to cover the seed. So we can see in the picture they spreading the fertilizer after planting. So for the next slide, I will pass to next presenter, which is Azhar.
Okay, Assalamualaikum and a very good day. And thank you to for giving me a chance to present my slide, which is the proposed method for irrigation system in palm oil tree. So before I start with the proposed method, I want to explain what is irrigation means. So irrigation is the prerequisite for the good growth and production of any crops. Uh, As we know, palm oil tree is a fast-growing crop that need adequate irrigation. Otherwise, it will reduce leaf production, decrease sex ratio, abortion of inflorescences, and reduction of yield. So, based on my palm oil tree requires 100 to 265 liters of water per pump per day. So means that the amount of water affected by the condition of the day. So if it's during summer, it will require a lot of water. So I will continue to the proposed method, which is drippers and microjet. So as we can see in the slides now, for the dripper systems, it has four dripper placed at four sides of each pump. See, we can see at the first picture there there's a four drippers at the four sides of each of the pump, right? So each pump discharge 16 liter of water per hour, means that 4 to 5 hour is sufficient for the pump. And dripper should be checked for proper discharge of water. Means if the dripper has not been maintenance, it will affect the pump production. So move to the next proposed irrigation system, okay, which is microjet system. So two jets placed on either side of the pump. So as we can see at the picture, there's a blue microjet, one's in front of the pump and another one is behind the pump, the blue one. So if each jet discharge 40 liters of water, 2 to 3 hours of irrigation per day is sufficient. Uh, so the amount of irrigation increase due to high potential of evapotranspiration. For example, what I said before, if during summer it requires a lot of water. So for the best conclusion that I can make for this irrigation system is always provide the recommended quantity of water to avoid low water and nutrients. So I think that's all from my part. So next, Alicia, to continue the slides. Thank you, everyone.
So next, I will be presenting on the drainage system used for the palm plantation. So what is drainage? Drainage and water control are essential components of the oil palm peat growth process. Water management drainage systems are often comprised of an interconnected network of field, collection, and main drains, as well as canals of varied size and intensities, which are determined by the hydrological and rainfall features of the region. So next is the features contained in the drainage system. So there are three features. First is the perimeter bands. So perimeter bands are band construction dimensions that can be so the construction dimension can be determined as the following criteria. So there are three criteria. First is top, second bottom, and height. So the top criteria dimension is from 1.2 until 3.5 wide. The bottom is 4.5 to 10 meter wide, and the height is 0.6 above the highest water level. Second is the ring drains. So ring drains is a horizontal drain that runs parallel to the outside band. Perimeter band is formed using the soil or spoil duct to build the ring drain. So the outputs of the ring drain are contained inside the surrounding band, which is protected from flooding by water gates. Next is the field drainage network. So the field drainage network comprised of the following. First is main drains, second is collection drain, and the third is field drains. So main drains are determined by the area itself. Uh, the depth decreases from 2 to 1.6 meters in the bottom, and it eventually usually will reach to 2.5 meters. So usually collecting drains provide water to the main drains, which convey it to different sites such as river, water gates, or ring drain. The main drains are usually constructed parallel to the major or sub-major roadways. Second is the collection drains. The distance between collection drains and main drains may vary between 400 and 800 meters. And the collection drain is usually 2.27 meters in length from top to bottom, and it has an overall depth of 1.78 meters. Lastly is field drains. Field drains is parallel to the pump rows, and it flows into the collection drains that are perpendicular to the field drains. Last, Next is the planting pattern of suggested for the oil palm plantation. So it may be split into blocks or fields that comprise both immature and mature plantings in order to make planting operations easier and more efficient. A 9-meter interplanting distance are suggested to separate the oil palms, which are laid out in triangular rows. It is recommended that the planting density for oil palms is 130 until 140 palms per hectare, and the terrace planting will be used in steppe terrain to reduce the runoff and increase planting density. Last is the conclusion. So it can be concluded that the land appraisal for oil palm growth has proven to be beneficial using geospatial information technologies such as GPS, RS, and GIS. Planters that have knowledge about this software and materials may predict the parameters need to be considered. As technology advances, the technologies will become a lot easier to use and more extract. The GIS database created in this way can be utilized for a variety of purposes. So that is all for our group's presentation. Thank you.